All right, so we are going to rewrite some equations in factored form. But first, what we're going to do is look at which one of these doesn't belong. Now, you can have arguments for all of them, but I naturally chose A, and the reason A is in factored form compared to the rest, which are in standard form. Now, you can think of other arguments for why B, C, and D don't belong that are in standard form. So if I notice for B, the coefficient of A is equal to 3, and for C and D, that coefficient is equal to 1. Why C might not belong? So I notice here, there is no X term. And then for D, why D doesn't belong? Well, I notice minus signs and all the rest, and this is only positive signs. So our next activity is moving from factored form to standard form, and then moving back for the second one from standard form with the coefficient for A that's larger than 1. So I'm going to do this one by distributing. So 3x times x is 3x squared, and 3x times 4, I would put plus 12x, and then 1 times x plus 1x, and then plus 1 times 4 plus 4. So in combining those like terms, we have 3x squared plus 13x, and then plus 4. Another way to do that is with a rectangle model. So I'm going to draw a rectangle model. We have 3x and 2, and then x and 2. And then here, 3x times x is 3x squared. 2 times x, 2x. 3x times 6, 6x. 2 times 2 is 4. Combining my like terms, I have 2x and 6x, which is going to make 8x. So the first term is going to be 3x squared. I'm going to write that first. And then plus my 8x. And then plus my 4. So now I'm going to show you how to do that and do distribution without showing your work in the middle. So 3x times x makes 3x squared. 3x times 1, I'm just going to remember, I'm going to add 3x. And then 4 times x, I'm going to add 4x. And 3x plus 4x, I'm going to add 7x. And then lastly, I add 4 times 1, which is adding 4. So it's a little bit more difficult than even me as a math teacher finds moving from standard form to factored form and factoring when you have a coefficient for A. It's difficult because there's no set process to do that. It can be a lot of trial and error. So I'm going to use a rectangle model to model the first problem. And I know here we have 5x squared. And then my constant term 4 is going to go here. And I know that these two terms, I'm going to have to add up to 21x. So I'm just going to try here. I know that I might have 5x here and x there. And then for 4 and 1, I'm just going to write over here 1 and 4 because I don't know that this is going to work. And then I'm going to put in the upper right-hand corner, if I multiply, this would be 1 times x, which is 1x. And then 5x times 4 would be 20x. And then adding 20x plus 1x, that actually does work. So I factored it the first time. I'm going to rewrite that. And this is going to be 5x and then plus 1x. A lot of the students struggled with having the factors on the outside and knowing that this was 5x plus 1 on the outside in factored form. And then here, this x and 4, well, that's a positive, and I can put parentheses around that. So that would be x plus 4. So now 3x squared plus 15x plus 12. Well, I'm going to get my rectangle diagram ready. And I have 3x squared, which I see we can have 3x and x. And then I'm going to put 12. Now I can combine these and make 15x there. So how I'm going to do that is just put factors of 12. And if I'm going to put f for factors of 12. And you could have 1 and 12, or 2 and 6, or 3 and 4. So I'm just going to start. What if I put 1 here and 12 there? So multiplying 1 times x is 1x. 12 times 3x is 36x. That's going to be too much. So now I'm going to switch. What if I switch the 1 and the 12? So 12 times x is 12x. And 3 times x would be 3x. And then when I add 12x and 3x, that does add. So what I'm going to do there is put in my 12 and put in my 3x, my 12x and 3x. And then I'm going to put my 1 big and put it in parentheses, and 3x plus 12, nice and large. So I have 3x plus 12 times x plus 1. And then lastly, we have 6x squared plus 19x plus 10. So in here, I'm going to put 6x squared and then a 10. So to break up 6x squared, I'm going to try 3x and 2x first. I also could try 1x and 6x if that doesn't work. So now I need factors of 10, which are 1 and 10, and then 2 and 5. So I'm going to start with 1 and 10. So I know if I put the 10 here, I'm going to make 30, so that's too big. So I'm going to try 10 here and 1 here. So 10 times 2 is 20. That's already too big. So I know 1 and 10 don't work. So now I'm going to try 2 and 5. Now I'm going to put the 5 here and the 2 here and see what happens. 2x times 2 is 4x. 3x times 5, 15x. And when I combine my like terms in the middle, 4x plus 15x is 19x. So that does work. And then just a reminder, we have 3x plus 2 on the outside. And then here we have 2x plus 5. So for our last problem, we're going to do an application problem. So an engineer is designing a fountain that shoots out drops of water. The nozzle is launched from 3 meters above the ground. It shoots out water at 9 meters per second. Here's the function. How many seconds till it hits the ground? So write an equation that we could solve that. So if it's hitting the ground's 0. So my equation would be 0 equals negative 5t squared plus 9t plus 3. And then to factor that, well, if I were to factor this, it's actually not easily factored, and I don't exactly know how to do it with a negative in front. So I'm going to put I can't. And then try to solve it by graphing. So if I solve that by graphing, I'm going to press y equals, clear out what's in there, put in the function, negative 5. I have to put x in front of t, so x squared, and then plus 9x, and then plus 3, and then graph that. And then I'm looking for my 0 there. So if I calculate by pressing second trace and go down to my 0, and I go to the left, and then I go to the right, I see it's about 2.09 seconds.